Hardening involves heating of steel, keeping it at an appropriate temperature until all perlite is transformed into austenite, and then quenching it rapidly in oil. Heat treatment is a critical and complex element in the manufacturing of gears that greatly impacts how each will perform in transmitting power or carrying motion to other components in an assembly. Heat treatments optimize the performance and extend the life of gears in service by altering their chemical, metallurgical, and physical properties. Heat treatments also improve a gear's fatigue life by generating subsurface compressive stresses to prevent pitting and deformation from high contact stresses on gear D. Gear manufacturing. Know all about the gear production process. The idea of gears has been around for a while, since they are among the oldest mechanical components still in use today. Be it the auto industry, the aerospace industry, industrial equipment, or even something as basic as a clock, gears are used everywhere. A variety of processes can be used to manufacture gears, including casting, forging, extrusion, powder metallurgy, and blanking. As a general rule, however, machining is applied to achieve the gear's final dimensions, shape, and surface finish. Did you know? Gear dimensions and teeth are the most critical components that require the highest level of precision in the final product. Overview of the gear manufacturing industry. Gears must function under extremely poor circumstances to transmit power, which is their intended function. First and foremost, the gears must be in flawless condition. Then they must always be trustworthy, have very low to no probability of crack propagation, and have almost no residual strain. Naturally, it is very challenging to meet all those demands in equipment manufacturing. Because of this, the fabrication of gears is a highly specialized industry with very limited scope for errors. Gear manufacturing process. A gear manufacturing process involves multiple layers of work to deliver the best quality. However, the following is the generally practiced gear manufacturing process in the industry. Casting. The teeth are manufactured by machining, and blanks or cylinders for gears are often prepared through a simpler method called casting. Due to its potential for mass production and relative simplicity, it is a suitable method for producing gears for numerous purposes. However, casting is the preferred manufacturing technique for large gears. That is how huge gears are produced. Large dimensions make machining techniques and other gear building techniques less practical. Large gears are typically spur gears. Casting is a very wise choice because of its relative simplicity. The most popular casting techniques for making gear include shell casting, die casting, sand casting, and permanent mold casting. Forging. Depending on your needs, this shaping technique can provide you with both blanks and ready-to-use gears. If your gears are simple, forging is a viable option. Theoretically, forging is a highly effective method of producing gears for heavy-duty applications. Heat treatment is necessary during forging, so the finished gear will have improved fatigue characteristics. However, the size and thinness of this technique are constrained by the enormous force needed for forging. Forging typically works well for gears with a diameter of 6 to 10 feet. Form milling. In form milling, the gear tooth is created by moving a cutter, known as a form cutter, axially along the length of the gear tooth at the proper depth. The cutter is removed, the gear blank is rotated, and the process is repeated to cut another tooth. The procedure is repeated until every tooth is removed. Broaching. Broaching can create gear teeth, which works particularly well for internal teeth. The procedure is quick and generates a high degree of dimensional precision and exquisite surface quality. However, this process works best for high-quality production because broaches are costly, and a different broach is needed for each gear size. Gear generation. When creating a gear, the teeth flanks are created as an outline of the cutter's upcoming positions, which are shaped similarly to the mated gear in the gear pair. The two machining techniques used are milling and shaying. These procedures can be altered in several ways depending on the cutting tool used. Gear teeth are gradually produced during gear hobbing machining using a sequence of cuts made with a spiral cutting tool. The hob and gear blank constantly rotate like two gears meshing throughout the whole hobbing process until all teeth are cut. Powder metallurgy. The field of powder metallurgy has advanced significantly in recent years. These days, it's employed in a variety of manufacturing procedures, including the production of a gear. It appears quite simple from the outside, but there are lots of tasks involved. Metal powder is where it all began. The first step to begin with is to take all the powder and give it the final form you desire. Blanking, extrusion, and blanking are extremely similar processes, although blanking only works in two dimensions. With the aid of numerous dies, this gear-forming procedure employs sheet metal to produce the necessary shape. The best results, however, are provided by spur gears. Today, various industries use the gear blanking method for lightweight application.